When designing human-machine interfaces, or HMIs, the color of buttons isn't just a matter of aesthetics. It's a crucial aspect that can affect safety, efficiency, and user comprehension. Imagine you're in a control room, and you need to quickly identify the status of a machine. The color of the button can instantly communicate whether the machine is on, off, or in an error state. This leads us to the question, are there specific norms or standards for HMI button colors? The answer isn't straightforward, as it often depends on industry standards, machine directives, and even the same norms for electromechanical actuators. However, a common practice is to use green for safe, normal operation and red for danger or error states. But there's more to it than just these two colors. For instance, yellow often indicates warning or caution, while blue might signify information or a neutral state. Understanding these norms is vital, especially when dealing with complex machinery where misinterpreting a button's color could lead to severe consequences. And here's why that matters. Adhering to these color norms not only enhances user experience but also ensures compliance with safety regulations. In the next segment, we'll explore the specific standards and guidelines that can help you make informed decisions about HMI button colors. To understand the color norms for buttons and lights in human-machine interfaces, let's delve into the theoretical basis. The machine directive, a cornerstone of safety standards, offers guidelines that are crucial for HMI design. Green typically signifies safe to operate or normal operation, while red warns of danger or fault. Yellow or amber often indicates caution or standby. These colors are not arbitrary, they're based on human perception and reaction times. For instance, red is universally recognized as a stop signal, prompting immediate attention. Green, on the other hand, is associated with go or proceed, encouraging a sense of safety. When designing HMIs, consider the context of use. In a manufacturing environment, green might indicate a machine is ready to start, whereas in a medical device, it could mean the device is functioning correctly. Always align color usage with the user's expectations in the specific application context. And here's why that matters. The SE, or Comitato Elettrotecnico Italiano, has established specific norms for the color coding of electromechanical actuators. These norms are crucial for ensuring consistency and safety across various industrial applications. For instance, green typically signifies a safe or enabled state, while red indicates danger or a disabled state. However, the interpretation can vary based on the context. For example, in some setups, green might mean the machine is off, and red means it's on, depending on whether you're prioritizing safety or operational status. Understanding these norms is vital for effective communication and safety in industrial environments. Let's dive deeper into the practical applications of these norms. Now, let's dive into practical examples. Imagine an HMI interface with multiple buttons for different functions. Green typically signifies normal operation or safe status, while red indicates an alert or danger. For instance, if you have a button controlling a motor, green might mean the motor is off, and red means it's running. However, this can vary based on context. If the motor is part of a larger system, green could mean the system is ready, and red could mean it's active. The key is to align the color coding with the specific function and context. Always ensure that the color scheme is consistent and intuitive for the user. Remember, the goal is to provide clear, immediate feedback on the system state. Understanding the nuances of button colors in HMI systems is crucial for effective communication and safety. Let's delve into some advanced considerations and common pitfalls. First, remember that color conventions can vary based on industry standards and specific application requirements. For instance, in some contexts, green may indicate a safe or normal state, while in others, it could signify an active or dangerous condition. Always verify the specific standards relevant to your project. Another common pitfall is assuming that color alone is sufficient for user comprehension. It's essential to combine color coding with clear labeling and, where possible, auditory feedback to ensure accessibility and clarity. Additionally, be Be cautious of color blindness. Approximately 8% of men with Northern European ancestry have some form of color vision deficiency. Use patterns or textures alongside colors to convey information effectively. Lastly, when integrating new HMI elements, thoroughly test the interface with end users to gather feedback and make necessary adjustments. This iterative process ensures that the HMI is not only functional but also intuitive and safe.